This is a NEET 2013 question in magnetism and matter. It says a bar magnet of length L and dipole moment M. So, first let me write what is the meaning of that dipole moment. When he says a bar magnet, it is having a north pole, south pole. It is given that the length of that bar magnet is L. It has north pole and south pole, which has a pole strength M. Then the magnetic moment is defined as any one pole of pole strength M multiplied by the length of the magnet is called magnetic moment M. That is what he says. It is M. It is now bent in the form of an arc like this. It was bent in the form of an arc. Now, this arc has a length L, right. The new magnetic moment is, again, new magnetic moment M dash means even when you bend, the length between them remains the same, the magnetic pole strength remains the same, but the distance between the poles is no more L like this, rather it is here like this, which is different from that of L. So, I have to find the distance. So, if I bisect this angle, this becomes angle theta by 2. If I call this distance x, this distance also becomes x. So, new magnetic moment becomes m into 2x. If I calculate that x, I have done my problem, I have solved the problem. Let us see how do I calculate that x, right. So, let me redraw the diagram for us again. A magnet is bent in the format of an arc like this. This is the north pole, this is the south pole of the same bar magnet. The length of that arc is L now, because the same magnet is bent, but the distance between the poles is this, right. So, this arc makes an angle at the core, at the base, that angle is theta, that angle can be bisected now. If the total angle is theta, this becomes theta by 2, this becomes another theta by 2, this distance becomes x, this distance becomes x. So, the total distance between them becomes 2x. This is the origin of the arc, this is the radius of that arc. So, if you observe a little carefully, there is a right angle triangle here, and x I have to find out. So, I can write in that right angle triangle, sin theta by 2 is opposite side by hypotenuse x by r. That implies x equal to r sin theta by 2. So, I got x, but I do not know the value of r because radius of the arc is given for us, not given for us. How can I find the radius of the arc? Basing on the core definition of the angle. Angle is always defined as arc by radius. So, the total angle theta, this angle theta, arc is given for us in the problem because the magnet itself is bent like an arc by radius r. It implies r can be written like L by theta. Put that arc value in this equation. That implies x becomes, in the place of r, L by theta sin theta by 2. I got the value of x now. Put that x here in the magnetic moment. So, that implies what we can say is new magnetic moment is, when it is bent like a arc, m dash equal to small m 2 into x. I got the value of x in the terms of given data, L by theta sin theta by 2. M into L is the original magnetic moment. So, in the place of m into L, I can write original magnetic moment and 2 is there. So, 2 into original magnetic moment sin theta by 2 by theta is the expression for the new magnetic moment when a magnet is bent like an arc. This is how I can derive a formula. Without substituting the data, I have derived the formula so that you can use it further. Now, it is given that theta is 60 degree in the problem. I can substitute, this is given for us. I can substitute now. So, new magnetic moment is 2m sin 60 by 2. Be careful here, you shall not write 60 because you are in a SI system. You have to write this theta always in radian. 60 degree is pi by 3 radian. 180 degree is pi. So, that implies 2m sin 30, sin 60 by is sin 30, that is 1 by 2 by pi by 3. This 2 and 2 will cancel, this 3f the denominator comes to the numerator. So, that becomes 3m by pi. That answer is there. So, that is the answer. Sometimes people extend this answer further also, as though it was not done here, pi can be written like 22 by 7, right. So, this will become 21m by 22. This can be expressed in this way also, if that is not anyway expressed in here in this problem, right. That is how we have to solve the problem. The core formula for solving this problem is magnetic moment is the magnetic pole strength, any one pole strength multiplied by the distance between the poles. Once if you know that concept, you can just go ahead and solve the problem. That is it. Thank you for watching.